Which element in each pair has the greater first ionization energy? Ionization energy is the energy required to remove the outermost electron in an atom or an ion in the gaseous state. And the first ionization energy refers to the energy required to remove the outermost first electron. So the general trend on the periodic table is as you go up and to the right, it requires generally atoms require more energy to remove those outermost electrons. They're just bound more. They're more attracted to the nucleus, the atom. I'll just keep that up there. All right, let's do A. Lithium and boron. So these are in the same period. Usually give you problems where they're in the same period, and then you're like the answer is to the right, or in the same group, and the answer is going to be the one higher. And then we wouldn't give you like something like that. That would be, we wouldn't do that. Or we can give you something right on this trend line. Then that would be even easier. So boron and lithium, they have the same shells or energy levels. So lithium has 3 electrons, 2 in the first energy level, 1 in the second. We know it's not in orbits like this, but it helps when you draw it out like this for these kind of problems. So boron has 4 electrons like that. And these electrons on the outside, and right there, right there, right there. Let me just highlight one of them because it's only trying to remove one of them. All right, they're both in the n equals 2, and they're both, what that means is they pretty much have experienced the same amount of shielding. Now, this one has a little more shielding, but it's really the primary factor is the nuclear charge. And so lithium having 3 protons and boron having 5 protons, right, with the shielding factor being about the same, this electron, that outermost electron from boron, is going to be much more attracted to the core, the nucleus, than lithium's valence electron. So it's going to be harder to remove. It's going to require more energy. That's the reason as you go across the period, because Z increases, the nuclear charge increases, so the effective nuclear charge is. So boron is the answer there. Let's move on to B, magnesium, strontium. Now these guys are on top of each other, so it's a different reason why. So magnesium is going to be the answer, because if you just want the answer, you just follow the trend, up and to the right. So let's just circle that. That's going to be your answer. Magnesium requires more energy because it's an n equals 3. Right, 1. Right, so this is n equals 1, n equals 2, n equals 3. Its valence electrons, which it has 2 of, is going to be on the third shell, third energy. What are we doing there? Strontium that's like n equals 5, right? There's 4, there's 5. It's in the. All right, so strontium. 1, 2, 3, 4, and 5. So not only are the valence electrons for strontium, let's just pick one of them. All right, like this guy and this guy. Which one do you think is going to be easier to remove? All right, hopefully you're saying the strontium's valence. It's easier to remove because, look, it's just farther from what it's attracted to is the nucleus. All right, not only that, strontium, these 2 electrons, right, are both experiencing 36 other electrons beneath it. There's 36 electrons underneath it, just trying to block it from. They don't like each other. They're just negative. No pun intended. But their electrons repel each other, so you got 36 of them, layers and layers of them, just like go away. And so this guy's going to be pretty happy to leave. Not going to require a lot of energy. Right, so whereas this is much closer to the action and there's not as much blocking going on there. That's why magnesium, generally as you go up on the periodic table, is going to require more energy to remove those. Cesium and aluminum, now this is, they're not in the same column or row, but they are right on this trend line. So aluminum's there, cesium's down there. Like, doesn't get easier than that, right? So aluminum's going to be the answer, all right, for a combination of both those reasons we went over earlier.